Hello everyone, today I will be explaining the main components of a power bank and function each part. The power bank in front of you says I will take it I will take it all off. I will take each part and I will talk about the case, the metal, the wires, the battery pack, and finally the green circle board. The case. It is a gold case. It is like a shell, outer shell, so that all the interior components of the power bank, although it may seem like a simple part, it plays several important roles. First, it protects the entire components from physical damage. Power banks are often carried in bags, pockets, and vehicles, where they can experience impacts, drop, or pressure. The case acts as a protective barrier against the forces. Second, the case keeps all components securely positioned. Without the case, the battery circuit board and wire will move around and could become damaged. Another important function is user safety. The case prevents user from accidentally touching electrical components that could be damaged by electrical or short circuit. Finally, the case improves the appearance and property of the device. Manufacturers designed the case to be lightweight and attractive so user can easily carry them. In summary, the case provides protection, structure, safety, and property. This is the metal, silver metal. At first glance, this piece may not look important because it does not contain any electrical components. However, it serves several useful purposes inside the power bank. One of the main functions is providing structure support. Since the battery and circuit board must remain in fixed position, the metal plate helps keep everything stable. The metal plate can also act as a spacer between components that help to prevent movement when the power bank is dropped or shaken. In some power bank design, metal parts helps distribute heat generated by the battery and electrical circuit by spreading heat across a large area. Temperature remain low and the device operates more efficiently. Additionally, the metal plate helps protect sensitive interior components from excessive pressure that may be applied to the outside of the case. Although it's not an electrical component, it contributes significantly to the durability and reliability of the power bank. Now let's discuss the red and black wires. The wires are responsible for carrying electrical energy between the battery and the circuit board. The red wire is usually the positive connection, as we see, while the black wire is the negative connection. The color coding helps technicians identify the correct electrical wire during assembly and repair. Whenever the battery is being charged, electricity flows through these wires from the charging cycle into the battery. When a phone or a device is connected to a power bank, electrical flows from the battery through the wires to the green cycle board, which is proceed and delivered processed and delivered through a USB ports. Even even though the wires are small, they are extremely important because they serve as the main pathway for electrical current. If a wire becomes disconnected, broken, or damaged, the power bank may stop charging, stop supplying power, or fail completely. Therefore, the wires act like the transportation system of the power bank, carrying energy whenever it's needed. Let's talk about now the battery pack. The battery pack is the larger and most important component inside the power bank. These battery packs store electrical energy so it can be used later to charge phones, tablets, and other electrical devices. As we can see, the battery has 6 batteries inside of this shell, blue shell. These blue battery packs store electrical energy so it can be. Most modern power banks use lithium batteries because they can store a large amount of energy while remaining lightweight and compact. The battery works by storing energy through chemical reaction. When the power bank is charged, electrical energy is converted into a chemical energy and stored inside the battery. When a device is connected, the process receives the batteries, converts chemical energy back into the electrical energy, which can then power external devices. The battery is usually the most expensive component in the power bank because it determines how much energy the power bank can store. Battery capacity is measured in milliampere hours or mAh. Higher capacity means the power bank can charge devices more times before needed to be recharged. Because lithium batteries contain a large amount of stored energy, they must be handled carefully. Damage, overheating, or short circuit can create safety risks. For this reason, the battery always works together with the green cycle board, which manages and protects it. Let's talk about the green cycle board. Finally, we come to the green cycle board, or green GCB. The GCB is often considered the brain of the power bank because it controls all electron operation. The green board connects many electric components, including the circuits, resource, combined protective system. One of the most important factors in a battery management, the green circle board monitors charging and discharging to ensure the battery operates safely. It prevents overcharging, which could damage the battery and reduce its lifespan. It also prevents over-discharging, which occurs when the battery voltage drops to low. Another important function is short circuit protect. Short circuit protect. If a fault occurs, the GCB can disconnect the battery to prevent damage. Additionally, the green circuit board controls the USB output and the LED flashlight seen on this power bank. Without this, it will not work. and as you can see, it has two USB charging ports, and it has the light. And here, as you can see, the lighter for this, so you can see how much charge it has. Thank you for watching. Goodbye.